Okay, folks, so I'm going to go through some of the questions that I went through in our video hangout. That way, those of you who missed it will still be able to follow what we're doing and won't fall behind. A couple of questions specifically that students were having difficulty with, and some examples of how to do the work from the next section. Okay, so just as a quick recap, if I want to get the area of a rectangle, it is the length times the width. If I want to get the area of a triangle, it is half the base by the perpendicular height. So I want to talk about this first of all, just for a few minutes. This idea of base, okay? So if I got my triangle here, okay, and it's got a length here of, let's say, 7 and a height here of 3. Well, this is clearly the base, okay? But let's say I had another triangle. Okay? That's actually a bad example. Actually, you're a right angle triangle. That's slightly better, okay? Now that's the base, okay? Likewise with this triangle here, that's the base because this is the perpendicular height, but let's say I were to draw a line coming from the right angle from this corner here. This would be the base, okay? Likewise, if I've got say take this triangle here, well now we have, that's the base. In other words, the base of a triangle isn't the bit on the bottom, it's whatever bit the perpendicular height comes off. So in this example here, 4 is the base. In this example here, 7 is the base. In this example here, 5 is the base. So that's what we mean by base. It's not that there's one side that's correct. Any side can be the base of your triangle. You then just get your perpendicular height from getting a right angle, going up to the opposite corner from that side that you've picked, okay? And that is it. So if we look at a question from the book, say question 12, part 5. Okay, I've got a triangle with one side of length 24 and a height perpendicular to that is 13. Sorry, that's a 3. Okay, how's that? Yeah, it looks pretty good. Okay, so to get the area of this triangle, it's a half of 24 by 13, which is 12 by 13. 156 centimeters squared. Okay, so there we go. All right. Now let's look at another question from the book that some students are having difficulty with. Okay, question 16 from exercise 9.3. Okay, that would be for those of you who are using your books. That is, just let me get the page number up here. Page 204 of the textbook, but I've also been sharing pictures of these pages, okay? So, we've got a shape. It's a rectangle. Doesn't look quite like that, with a triangle coming off the side. It's more like that. Okay? We're told that this side here has a height or has a length of 10 and a width of 7 centimeters. And we're also told that the perpendicular height from the bottom of this imaginary line to the top corner of the triangle is 6 centimeters. We're asked to find the area. Well, this one's actually quite simple, folks. If this is 10, then this is 10. Okay? Now, this shape here, let's ignore the triangle. This shape here is a rectangle. So to get the area of this, it's going to be 10 by 7. 70 centimeters squared. And look, here we have a triangle. Okay? Half the base by the height. 30 centimeters squared. So therefore, the total area of this, 70 plus 30, 100 centimeters squared. Okay? Now, I'm going to do one more example from this section. Okay? 16 part 2. So we're told that 16 part 2 that the this height here is 16 centimeters. Okay? And then we've got this here is 10 and this here is 14 centimeters and centimeters. Okay? As to get the area. Okay? Well, folks, we have a triangle and we have a rectangle. Okay? This rectangle here we can get the area of instantly 10 by 14, 140 centimeters. Okay? Now if we look at this triangle here, okay? Well, it's a right angle triangle. So that means the distance from here to the top is the perpendicular height of the triangle. If from here to here is 10, then from here to here is going to be 6. And now we have our dimensions. If this is 14, then this is 14. So it's going to be a half 14 by 6, 42. Which is 182 centimeters squared. Okay? And there you go. I'm going to go over 18 as well, because yet again, this is something that people in the in our video class are asking about, had a bit of difficulty with. Okay, so question 18, we've got a flag, and it's got two shaded regions. In the book, they're shaded blue. Okay, now the dimensions of the flag are 90 centimeters by 70 centimeters. Okay, and the dimensions of these strips, this strip here is 20 centimeters wide and this is 10 centimeters wide. Okay, that's supposed to be a 10, folks. Centimeters and centimeters. Okay, so if we want to get the area, well, what most people would probably do is they'd say, okay, well, let's look at this. This is a 20 by 70 rectangle. So just multiply 20 by 70. That's going to be, I think, 1,400. Yeah, 1400 centimeters squared. And then they look at this one and say, okay, well, this one here is 10 by 90. So that's going to be 900 centimeters squared. Okay. Okay? And then they say, right, well, I'll just add that. And if you go to the back of the book, that's wrong. And the reason it's wrong is quite simple. If we think about what we've just done here, I found the area of this section of the flag going from here to here. Yeah? And then I found the area going from here to here. Well, if we think about that for a moment, folks, what's happened is this square here has been counted twice. So this 2,300 includes an area that's been counted 2 times, which we don't want. Now, how big is this area? Well, this area here is 10 by 20, so that's 200. So, if I want to get the total area, it's going to be this minus 200. Now, I only subtract 200 once, because I do want to count it still once, I just don't want to count it twice. So the actual area of the flag, 2,100 centimeters squared, not 2,300 centimeters squared. Okay, so I'm now going to move on to the next section in the book, because some people are finding these questions very easy, some people are finding it a bit more challenging. That's okay, you work at your own pace, especially now. We're moving on to the next section of the book, which is dealing with rectangular solids. Just give me one moment. Okay. So this is section 9.4 of the book, page 206 onward, okay? And this is rectangular solids, okay? So when we talk about rectangular solids, what are we talking about? What we're talking about is boxes, okay? Rectangular cuboids, okay? Now, if we're dealing with a rectangular cuboid, there's two things we might want to find. The first thing we might want to find is the surface area. Okay, so the surface area would be like the area of all these surfaces. So if this was a cardboard box, okay, and I were to unpack it, take it apart and lay it out flat, what would be the area of that space that I've covered, okay? Well, how we do that is actually quite simple. You just break it up into its 6, in this case, rectangular sides, or faces. Faces is the proper term here, folks. So let's look at this example, okay? So we'll say, I'm just making up numbers here. So we'll say that this box is a height of 2, a width of 3, and a length of 4. Okay? Well, I want to get the area of this face here on the left. So that's going to be a rectangle 2 by 3. Okay? Which is 6. We're assuming these are all centimeters. Okay? Now let's say I want to get the area of this rectangle here. Okay, well I know that the length is 4, but what about this side? Well, we know what that side is because it's over here. This is 2, so that means this is 2. This is 2 by 4, which is 8. And then we get, what about the top bit? Okay? Well, I don't have any lengths here, but I do. Okay? So this length here is 4, which means this length here is also 4. Alright? And this length is 3, so this length is 3. 3 by 4, 12. Now, some students might make the mistake of saying, okay, so that's great, so just add up 12 and 6 and 8 and there, I'm done. No, you're not. Because you have to remember something. We're drawing a picture of a 3-dimensional shape on a 2D surface. So yeah, I've got this top here of 12, but the bottom is also 12. So it's going to be 12 plus 12. Okay? This end here is 6, but the other end is 6. Plus 6 plus 6. Alright? And the front bit here is 8, but the back bit here is also 8. 8 plus 8. So that's 12 plus 12 is 24. Plus 6 is 36. Plus 8 is 44. Plus 8 is 52 centimeters squared. Now what we could have also done is 12 plus 6 plus 8, okay, which is 26, and then times that by 2, folks, which would have also given us 52 centimeters. Same thing, okay? That is how we get the surface area, okay, of our rectangular solid, okay? So our rectangular solids. Now, the other thing, so let's take a minute to look at this. Make sure you've got it. If you don't fully get it, well, there's a video. You'll be able to rewind it and look back over it again, okay? And of course, if you still don't get it, as I keep saying, email me, folks, okay? So, let's rub some of these numbers out, okay? Go back to the basics. So I got my rectangular solid, my cardboard box of a height 2 centimeters, a width of 3, and a length of 4, okay? And I want to get the volume of it. Now, first of all, what does volume mean? Volume in maths is the name we give for how much space an object takes up, okay? That's what volume is, all right? So how much space does the object take up? Okay? That's what volume means, all right? So physical amount of space. Area is how much space it covers, 2D. Volume is 3D, okay? How much space in space it occupies, okay? Formula for the volume of a rectangular solid is really easy. It is the length times the width Why, that's area, sir. Yeah, times, we're dealing with 3D now, folks. So we have a third dimension, the height. It's that simple. These three numbers, the length, the width, and the height. So if I want to get the volume of this rectangular solid, 2 by 3 by 4. 2 by 3 is 6 by 4, 24 centimeters cubed to the power of 3. Why to the power of 3? Because we're multiplying by 3 dimensions, length, width, and height. Area, power of 2, because we multiply by 2 dimensions, length and width. And that, folks, is how you get the volume of a rectangular solid. Okay? I'm going to do another example here, and then we're going to leave it. Well, actually, I'm going to do 2 more examples. So let's look at another one. Now, right, so we've got this rectangular solid, okay? It's got a length of 2, it's got a width of 2, and it's got a height of, we'll say, 10. And I'm asked to get the surface area. Okay, so let's get started. Well, we can straight away get this front bit here. 10 by 2, 20. I want to get this bit here, but I don't know what these heights are. But wait, I do, because it's 10 here, which means that is 10. 10 by 2, 20. And now we just need to get the bit on the top. But I need to figure out what the dimensions are. Well, if this is 2, and that is 2. And if this is 2, and that is 2. 2 by 2 is 4. So the area of this would be 20 plus 20 plus 4 multiplied by 2, folks. Why? Because there's 2 of each. We've got a facing here, but there's one at the back. We've got a facing to the left here, so there's one on the right. We've got a facing on the top, so there's one on the bottom. So it's times 2. 20 plus 20 plus 4, 44 times 2, 88 centimeters squared. Okay? And now to get the volume, the length, 2, by the width, 2, by the height, 10. 2 by 2 is 4 by 10, 40 centimeters cubed. Okay? So there you go. I want to do one more example, folks. Okay? So far we've looked at rectangular solids. Now I want to look at a similar but slightly different shape. And that is a cuboid. Oh my God, sir, what does this mean? Well, very simple. A cuboid, or a cube, is a three-dimensional shape. Now we're all going to assume that I'm able to perfectly draw on this rickety whiteboard that I picked up before the shutdown, okay? So you can slag me in class when we get back to school about my crappy drawing, especially all of you folks doing woodwork and technical graphics, okay? So we're going to imagine I've drawn here a perfect cube, okay? What does that mean? All of the sides are the same length. So in this example here, my cube, it has a width of 3, a length of 3, and a height of 3. Okay? So if I want to get the surface area, if all 3 sides are the same, then all 6 faces are the same. It's basically like a die. Okay? Like, you know, a 6-sided die. So, get the side of one side, 3 by 3, is 6. And the area is going to be 6 times 9. 54 centimeters squared. Okay? Trying to avoid blocking this thing. And there you go. Now to get the volume, it's the same thing again. The length, which is 3, by the width, which is 3, by the height, which is 3. Or I could have just gone 3 to the power of 3. Either way, it's still the same. And that's it. When we have a cuboid, okay, a cube, so something where the lengths of all 3 sides, the height, the width, and the depth, or sorry, the height, the width, and the length are all the same, then you just cube that number. And how do we cube it? Well, there's actually a power of 3 button on your calculators. If we all look, it's right there, power of 3. Okay, it's like 4 buttons up from the 8. Okay, If you wasn't sure which one, you could also hit that button there. Okay, so we could go 3. Oh, I hope I turned it on. We could go 3. Hit this button up here. The X with the square in the corner. I don't know if you can see there. It's giving me an option to enter a number. Okay, and then equals. Okay? Now, 3 by 3 is 9. 9 by 3, 27. 27. 1 centimeters cubed. So there you go, folks. Okay? Now, we're going to have another class, probably Friday. All right. See how we're getting on. Right now, what I want is all doing for me is try and get as many of these questions done as you can. Okay? I'm going to put up some more pictures up to questions 25 of section 9.3. And then I'm going to put up the first 2 pages maybe of 9.4 in your book. Okay? Yeah. If you can get them all done for Friday, great. If you only get some of them done, that is fine too. You just do your best. And if you have questions, people are sending me messages on Google Classroom. You can email me. You can also put a comment in the initial document where I share the assignment. That way everybody else can see your question if you want, because other people might have the same questions. Yeah, but if you want to send me questions by private, that's cool as well, okay? So I hope this makes sense. You have my email. If you have questions, by all means, email me. Take care. Don't be wrecking people's heads in the home, and remember to wash your hands.